Okay, perfect. So, good morning, everyone. Yeah, and I'll start with the presentation with a note of apology. I mean, we could have started it a few minutes earlier, but we were having technology glitches, so I had to last minute switch computers and all. Fun times. That's what COVID brings us, but definitely makes us more resilient. How different industries have evolved and identified new ways to sustain. That's really commendable, and that's what all essentially reflects that no matter what situation throws us at, and we figure out a way to navigate and evolve through it. With that in mind, today I'll talk a little bit about my point of view around as we take our analytics journey to modern ecosystems. What type of considerations you should think through, pretty much a reflection of my personal experience and my professional experience in this area. Feel free to kind of ask me questions here, and most importantly, just to let you know, this is super high level. This is not like a blueprint for you for success for to be successful in the cloud and the analytics space. However, this will give you some thinking points as you embark on a journey of integrating analytics and cloud as a coherent construct. I call this slide as reference architecture. This is not again this is not necessarily a technical architecture. It's more of a reflection of thought process. With that, like the very first thing I want to talk about here is industry consolidation. So going back like many years, like when the dot-com bubble, the web bubble came, there were thousands and thousands of companies who would like embark into the space, and they would try, or they would be all trying to solve the same problem, or they would all try to grow as the next leader in the area. And that's what's happening in the ML AI analytics space today as well. So if you look at, there are so many companies who are calling themselves as AI companies, ML companies. Their value propositions and value statements are give or take the same, but not every of those company will survive and become like large enterprises in future. But that's where the opportunity is, because this is a new space and everybody wants to be part of that opportunity, and everybody wants to be essentially ride the wave. And that the history has proven the same thing happened in the dot-com side, same thing happened when CRM evolved, and the same thing happening today is when there are a proliferation of analytics and AI companies. But what will happen eventually, as history suggests, that there would be an industry consolidation, and that industry consolidation will lead to two things. One, some companies will merge to become a larger company. Some companies will go out of business, and a few will sustain. So that's always the case, and that's why it is very important that as we think about our analytics strategy, especially when we are thinking about the technology that we are considering for our analytics ecosystem, we must always think about what is again, we all do not know what the future is, but we always must think about where the future may go, and make our technology decisions accordingly. What I want to say here is, like, before we essentially commit to a particular technology, particular organization who provides AI services, we need to do some assessment of whether 5 years from now, whether their business model is sustainable or not. And if their business model is not sustainable, and particularly if you are committing your technology ecosystem with those companies, are you putting yourself at a risk if those companies merge or acquire, or particularly go out of business as the industry matures? And that's what this Gartner's Magic Quadrant also represents, right? If you look at the Magic Quadrant, in this is like essentially a view of the quadrant a couple of years ago. Then if you look at the view of the quadrant today, and I'm going to go back. So this is the view of the quadrant in the past, a few years ago, as of like 2017, and this is the view of the quadrant just in 2019. So and 2020 it has changed even more. So I used 2017, 2018 to show not just going back 2 years, the difference is so much. And now if you look at the current one, if you like Google Gartner's Magic Quadrant for AI and analytics vendors, the quadrant would be much more different. And that is the reflection of how industry is getting consolidated, and that is fundamentally the reason that as you choose your cloud technologies, as you choose your analytics vendors and partners, you need to be quite cognizant of the fact that the industry is rapidly maturing. So that maturity also comes with a factor that some they become laggards, and some of the laggards then become leaders, and then and the shift is very, very rapid, right? So essentially individual companies, like large companies such as IBM's and Microsoft's of the world, sometimes they are left behind with smaller and newer companies because they have a new mindset, or they have a better understanding of industry problem, or they are more nimble, they are more agile at times, so they can enable capabilities that are very difficult for larger companies to navigate and enable. But sometimes those larger companies end up buying smaller ones, and a good example of that was how Salesforce acquired Tableau last year. Like, not that Tableau was a smaller company, but that was a clear reflection of that industry consolidation. So we all have seen the hype quadrant of Gartner, right? Like how different technologies are evolving from one stage to another. One of the areas that is evolving rapidly today and is an area of interest, particularly for me, is 5G. Being a part of a telecommunications company, right? Like 5G is one of those spaces where all we know is it's a technology that is going to give us like low latency, high speed, but it is not aligned towards a particular problem, right? Like when 3G came, it was more so for WhatsApps and Facebook messengers of the world, so that we can get into like connected messaging technology. Then and MMSs mostly. Then 4G came. 4G was more inclined towards it found space on streaming music and videos, like streaming content, like Spotify is Apple Music and Google Music, Netflix, Amazon Prime Videos. I mean, so all of them they took precedence as 4G became more democratic in nature. And 5G brings us low latency. So one of the areas that we can immediately see with 5G is gaming, right? Like maybe mobile gaming is going to, and game streaming will become like a norm, and that immediately opens a variety of analytics use cases and ML use cases. For example, what game to offer, where to offer the micropayment services, or what not to offer, how we can ensure that during the peak 5G service, what type of like this, what essentially during the peak 5G service, the services are available, and there is no latency disruption, almost pre-predicting our network traffic. There are many of these use cases, so it's kind of in a hype area, and it will go down. So and so do for many other works, many other functions that will go through this hype cycle, and so do ML AI. It has already passed the hype cycle, and that's why it has reached a point where industry consolidation has started happening. So we need to be very cognizant of the fact that industry consolidation is happening, and that is the reason we need to think about, when we are selecting a technology, are we going to select a technology that will probably erode away or will get consolidated and diminish in its value. And that's why assessing that, so this would be the hype cycle curve, would be essentially an evaluation tool for you when you select an MLAI technology for your ecosystem. So the question is, like, why do you care, right? Like, why do you care, and why it is there for you? Like, if you are a data scientist, why it is important for you? If you are a AI ML strategist, why it is important for you? And the reason behind you should care about it is analytics is a journey, right? Like, because you might be building models today, you might be deploying models after that, you might be operationalizing models after the day after, but at the end of the day, if you are stuck with a legacy technology that hasn't evolved, then your ability to innovate will diminish over the course of time. It's like almost like a good example of this is, let's say if you have an Android operating system in a phone, And I guess the latest Android operating system is Android 10, if I'm not mistaken. So if you have a phone with an Android operating system 7 and the latest one is 10, you would find that you are not able to download and utilize many apps that the Google Play Store offers. Or you might find that if you are a developer, you are not able to develop certain apps and certain functionalities, or use certain APIs that Google provides, because you are essentially stuck with an older operating system. The same thing, using the same analogy, this will apply here. So if you choose a wrong technology and you are stuck with that wrong technology, because these technologies are not often cheap, right? You would buy these technologies at a premium cost. You won't have an opportunity to go back to your organizational leaders and ask for money again to buy another technology. So if you make a wrong choice, you are stuck with that technology. And if that technology is legacy and it's not updating itself as systems are changing, then you are at a point where that's limiting your ability to innovate in the company. And that is fundamentally the reason you should care. So that's why that's essentially. I'll take a pause here and I'll reiterate two lines here before we go to the next section of this presentation. One, industry consolidation and industry amalgamation is inevitable. It is going to happen. In the history, it has happened many times. So it is quite pertinent for us to understand where the industry is going and select the technology accordingly. Second, why you care about that, the reason behind you care about that, because your ability to innovate in future is a function of what technology you select today and how well that technology matures in 4 or 5 years from now. Because you just won't innovate today and then stop innovating, right? You will be innovating and pushing the boundaries. And if the technology do not mature as the market is maturing, because of whatever reason they become obsolete, they do not have money, gets consolidated, or they go out of business, that is going to put your innovation curve at a large hindrance in future as well. And that is the reason you should care about these two things. And Gartner Hype Cycle, Gartner Magic Quadrant is a good way. That's not everything for you to do the research, but it's the good way to do research. And this is exactly where the cloud companies come into play, right? Because cloud companies are pretty much giving you hardware and software as a service. So the old concept of having a data center and in the data center you put your tools and technologies is going away at a very rapid rate. Essentially, everything, including your hardware and software, is a service now. So if you, let's say, need GPU for training your ML model, so this is like popular ML algorithms. This is nothing new, I guess. 99% of attendees in this call knows about these algorithms in one form or another. But if you, some of these algorithms, as you may know, will need high performance computing, for example, GPUs. Some of these algorithms, implementation of algorithms in an optimized way, may also need some modern data science frameworks, like let's say whether PyTorch and MXNet or so on and so forth. So if you want to utilize them, you can literally call them as a software as a service or infrastructure as a service through cloud vendors. So the whole idea of utilizing a hardware or running your ML AI workloads on your laptops or on your desktops, it's eroding away at a rapid rate. And I would humbly request the practitioners to also think in that way, that do you really want a hardware that is fixed in capacity and depend on that for all your compute requirements, or you want to depend on a as a service solution where if you need the GPU, you can call it for 15 minutes, train it, and then you decommission it and you don't pay for it. So essentially, sky is the limit how much your compute can elastically increase, and when you don't need it, you don't pay for it, and you can turn it off or put it in a sleep mode. And that's what cloud services are giving us. They are brilliantly intertwining hardware, software, and compute services, and as one coherent pay as you go package. And that's why you should care about cloud, and that's why cloud is an important forking point for success of ML and AI. With that, again, this is like open source libraries, and I spoke about some of these frameworks, and I have this slide just to remind and reiterate that these, irrespective of we are in a traditional legacy IT environment where we are doing compute in data centers, or we have power machines. Like, I mean, I was a huge fan of power machines in the past. Like I had laptops with like 64 gigs of memories and GPUs and all that, but like now I pretty much use my iPad for training models because my iPad is just like a keyboard and a screen, but my training is actually happening in the cloud services that I have subscribed to. And all these frameworks are available in the cloud services, and I am paying a lot less than constantly upgrading my laptop on a regular basis, because I'm just calling the service, using it when I need it, turning it off when I don't need it. And all these frameworks and I'm able to use. Yes, there is a learning curve, and that learning curve is everywhere. So we might as well learn today than having to catch up when the industry matures and everybody moves towards the cloud computing world of things. Okay, so there are with very high level, I'll talk about the different layers of cloud computing, right? The layers of cloud computing are IaaS, infrastructure as a service, PaaS, and so which is platform as a service, SaaS, which is like software as a service. So many of you may already know, right? Essentially what they are. But I'll spend a little bit of time here. And so, infrastructure as a service is essentially what the example that I just gave you. That I have a virtual machine running on cloud, and I turn on the virtual machine when I need it, run my workloads using anywhere, almost at anywhere in the world, and with any device, and then turn off the virtual machine. That's like the simplest form of cloud, which is infrastructure as a service. Then platform as a service is, let's say, a SQL platform, right? I have a SQL Server platform running on cloud where I'm running a database, and then management of the database, infrastructure behind the database, or upgrade and patching, all of that is taken care by my cloud vendor. And that's where platform as a service comes, where I don't care about the actual machine, but I actually log into the service or the platform that I need to use. How that platform is running, the OS behind it, and the infrastructure behind it is abstracted out from me. Then there is like one more layer of service where I don't even care about the databases or the platform or the technical subtleties or the intricacies behind the service. I directly go into my end application, which is like Office 365, for example, is an end application. Adobe Photoshop Suite, right, is an end application. Even Google Pages is an application, or Gmail, like per se. Like many of us may not know, like when we are accessing Gmail, we are actually using like software as a service. Like we are actually using a very sophisticated mailing app, but it is purely running on the cloud. And many of those, like many of those, in sometime knowingly or unknowingly, we are using software as a service and do not recognize that all that platform is running as a cloud. And although it's not truly a software as a service, but it's more of an entertainment as a service, I would call it. You should know that our Netflix and Amazon Prime Video also runs as cloud. So, and there is literally no physical hardware that Netflix manages for running their Netflix services. Like pretty much all of that is running on a cloud ecosystem. So essentially these are some old numbers, and I should have updated that, and I didn't get enough opportunity to kind of do a little bit more research and update those new numbers. But this will give you a sense of the spectrum where cloud services are going. So today the industry stands around like 270 billion in one form or another, and this is including all three layers in the pyramid. And that essentially presents the magnitude of where the industry is going. This is why I call this slide as reference architecture, because this is the crux of it. You can pretty much use this as a design pattern to think when you go into the cloud, particularly if you are in a role like mine, which is a hybrid IT analytics role. So I'm in IT organization, and my job is to enable data scientists and AI researchers and business intelligence developers and data engineers in my organization so that they can do their work with highest degree of efficiency by providing the right infrastructure and ecosystem. These are some of the things among many you need to think about. You need to think about how you will govern it. You would think about how your overall infrastructure will work. You will think about how your overall orchestration will work. How you need to think about how your users will interact with different modules of the system. You need to think about how would you make your system more secure. You need to think about like how would you service the users so that it gives the best user experience, and most of and the user experience is closer to a self-service centric mindset. And ultimately you need to think about, particularly if you're working in a regulated industry, where the telecommunications, whether it is financial services, these are all regulated industry. We are answerable to a regulator for what we do. You need to think about that, how you build that regulatory framework without compromising that user experience. And these are the areas you must consider as you are building your ecosystem. And even if you are a data scientist who never have to worry about this ecosystem, these are some of the questions you can ask your technology partners that, hey, like I have this solution. Did we consider about logging? Did we consider about auditing? Did you consider about, like, if my model goes into production, will my model be auditable in 5 years from now? If my model goes into production, will I be able to measure my concept drift and my model drift as new data comes into the play? Because the last thing you want, right? You stop innovating, and as data scientist, as an MLAI researcher, your job becomes tracing operational metrics around the model, and that will consume all your time because you won't be able to do your research. And the best way to do that is find the right IT partner who can enable those capabilities for you and do that, automate it for you, so that you can spend more time in doing the valuable activity and less time in operational framework design. This is another example of, like, I mean, essentially I oversimplified the last diagram. Another example of how we can use the reference architecture in a banking and financial services space, and what are the different players in the space, whether it is data scientists, data engineers, and what type of roles they play. So some of the things is like end user or the end customer really cares about the recommendation. Then the engineers and data engineers essentially care about building the data pipeline or data plumbing for you. Engineers would also care about, like, streaming AI services to the data scientist. Data scientists would also care about analysis of the data, which is also presenting the data in a more visual format, but they would equally care about building the right models and the MLAI capabilities. So that sort of at a high level presents how different what type of roles different users can play in designing an ML/AI application. And that's very important, right? Like, we all cannot do everything. So a clear delineation between different users is very important. And particularly when we go into the cloud journey, it becomes even more important, because you don't want to be a cloud administrator when you don't have to, right? So that's why delineation of those duties and responsibilities would also become a pivotal point for your success. Again, this is another example of a similar data application. So in interest of time, I won't go there. And then this is one area that I want to also highlight is, if you were to now build a churn analytics model, right, on cloud, you can pretty much build it in any cloud. And if you look at this is a solution which is entirely built on cloud. So this lowest level is essentially cloud-based microservices, and anything that you build on top goes on top of the cloud ecosystem. But then on the flip side, you're migrating your entire data loads to cloud. So for this to be successful, your entire data should be sitting on the cloud ecosystem. However, there are also possibilities where you can have a hybrid ecosystem where partial of your data is in the on-premise storage and partial of your data is in cloud storage. And you can have a security layer in between, and you can use both the capabilities, right, cloud and on-prem, to build a similar ecosystem that is enabling same type of capabilities. But again, contrasting both, these use cases and designs are very similar, but the only difference is this bottom layer, right? Where one is entirely on cloud with the fact that your data has to be on cloud, and which is a hybrid of cloud and on-prem. And the fundamental forking point here again is the security layer that essentially enables the intercommunication between on-premise and cloud storage. So it is more costly, by the way, when you have like a cloud and on-premise, but there are reasons sometimes, because of like security and compliance and governance reasons, why you may have situations where solutions are running in both cloud and your on-premise ecosystems, and that's why when you are building these capabilities, you do need to consider that what is your driving factor? Is cloud your driving factor? Is governance your driving factors? So on and so forth. So that is like essentially like I mean, there is a little bit of use cases that I have spoken about here, but that's obviously in interest of time, I'm not going into the details, and this is something most of you already know. So that's like my 2 cents on what we should do as part of cloud journey. So and yeah, that is it. Feel free to ask me some questions here. And I noticed an interesting pattern, which is like an infinite mirror formation. So when I share my screen here, if you look at, because I'm looking at my camera and then it's also getting reflected, so it's like almost an infinite number of mirrors that is reflecting on the screen. I found that pattern to be quite interesting here. So with that, I'll take a pause. Questions? I know we have about 6 minutes, so I'll try to address as many as them. I don't see any questions. I missed the last slide too quick. So essentially, Blair, the last slide was essentially a list of machine learning models or use cases, essentially where we can use supervised models, where you can use supervised learning mechanisms, where you can use unsupervised learning mechanisms. That is more as a I use that as a more of a concluding slide to say that, and irrespective of your use cases, you can enable cloud in like essentially use the cloud technology anywhere, but that I use that to reflect that it doesn't matter what your use case is, as long as you make your technology selections right, you will be able to enable those use cases anywhere. No, so no, I would. So Tyrone, your question is: are there any models that you would not move to cloud? Not necessarily. I think the only time I would consider about a hybrid ecosystem, if there is a compliance related constraint. If there is a compliance related constraint where we can't move our data entirely to cloud, but we want to take advantage of the computing capacity that cloud gives us, that flexibility, without having to move the data to cloud. And that's where the hybrid ecosystems are quite important, where you can use secure tunnels to use the cloud as a computing inference or a computing computing construct, and have your data stored in on-premise ecosystem, so that you're still keeping your data secured, maybe moving the data in motion to the cloud on a transient basis, getting all the compute done and bringing it back to the cloud using a secure tunnel, so that you are not constrained, at least with your limited compute capacity. And that's where that is the fundamentally why I would say that it is not use case or algorithm. It is more more on the data side, that what data your organization will allow or disallow to move to cloud. Okay, so would you like to have? So George has a question here. Would you like NLP to help to get insight from your employees to improve your change management? I created NLP and app. Would you then? Okay, yeah. So yeah, sure, George, absolutely. So can you discuss like politics? Yeah, sure. I think there is. Essentially, that's a key part of it. It's a fantastic question, right? Like, it's not about the technology, but it's also about the political journey, right? Like, because every leader in organization may have different stance, right? As we are embracing change, change is the only thing that never changes. So it keeps changing. It's a known fact, right? So in political navigation, you have to also understand like where, almost empathetically understand, right, where people are coming from. Your security organization may say like, don't move to cloud because there are areas which we do not know, or there might be IT infrastructure, data center folks. They might see that they will have a job loss if we move to cloud and they have no data center to manage. Essentially, the driving factor behind it, and this is not like a prescriptive solution, but this is more of a driving factor, is like, understand that where people are coming from, like why there is a pushback, why there is a change management, essentially, why there is a restrictions around change management. And more so, we need to think about reskilling and reutilization of people's skills. So as people are opposing an idea, they might be opposing not because they dislike the idea. They might be concerned that it might put their jobs at jeopardy. They might be concerned that it might change. They might have to embrace new capabilities that they don't have. So it has to come top down, where we need to reskill, retool, re-engineer our operating principles and processes. And that always happens, right? Like when, and it doesn't hurt to send the message that change is inevitable, right? It will happen, whether slower or sooner or later. We might as well embrace from the impact today than we try to scramble around when if we do not change fast, the business competitive framework will come at a jeopardy. What have you been? Okay, so a couple of other questions, and we, I guess, have 2 more minutes. What have been some of the challenges that you have been moving to? Yeah, fantastic question, right? That and I would be more than happy to even talk about it offline. Like probably my contact information was shared as part of this conversation. So many challenges. So first of all, lift and shift of your data to start with. Then building new security infrastructure, reskilling and retooling of people. Thinking about moving to, if we are just lifting and shifting our data center and not enhancing it, then we are not really truly taking advantage of the cloud. So thinking about what that future framework would look like non-standard lift and shift. It is not a like-to-like lift and shift. Understanding the future needs. Most importantly, making sure that we are doing it in the most cost effective way. And last but not the least, how do we train user community so that they feel comfortable with the change? How do we flatten their learning curve? We are all talking about flattening the COVID curve, but flattening curve is part of our daily lives, right? So for us, flattening the learning curve is very important. So I think we are at time. So if I don't think I can take any more questions. If I can, one of the organizers, if you can ping me and let me know. Otherwise, then I will take maybe more questions. Otherwise, okay, I can. So, okay, sure, I can take more questions related to okay, how are you? Let me related to the above, access to data systems, often productivity barrier at large enterprise. Can you give examples of how cloud services can be used to reduce the barriers versus more traditional on-prem IT system? Absolutely, I will use an example. Right, if you were to set up like a cluster with GPU enabled nodes for your high performance machine learning in a traditional system, just procurement, and this is, I'm talking about large enterprises, right? And there is nothing wrong. The large enterprises has their own processes, and that's why procurement of new hardware, setting up those clusters, setting up the OS, patching it up, and creating the GPU cluster for you is like a few weeks of activity. If you have done the right thing and enabled your cloud properly, then you can pretty much call your GPU instances and GPU clusters in matter of 2 hours, sometimes in even matter of minutes. So now whenever you need the GPU cluster, it can be built for you in 2 hours, and then once it is built, you can just turn it on and off as a service. So pretty much you turn on the switch when you need it, turn off the switch when you don't need it, and that way your procurement cycle is significantly declined for every GPU work that you need to do. And there are many such examples as you go to the cloud. And most importantly, cloud can almost infinitely scale, which our traditional on-prem bare metal data systems cannot scale. Fantastic question again. Fantastic question again. So question is, when we compare like running on cloud versus running on-prem, like is there what's the comparison, right? Are there specific applications? So in first few years, your cloud will cost you more than what it will cost you to run your on-prem data system, because this is OpEx versus CapEx, right? Like your capital when you are essentially buying a hardware, you're buying a new laptop, it's your capital, right? You're putting a capital on it, and then you will amortize that capital over a course of time. And this is literally, I sound like an accountant, but it is the fact. I hate accounting, by the way. So yes, you are essentially amortizing the services. But in an OpEx side, when you go to cloud, you are getting into CapEx, more of a we are going into OpEx, right? More of a operational expenditures, is the cost of doing business. Initially, what would happen, you would have a time frame where your cloud and your on-prem will run in parallel. So your cost would be much higher because you will be slowly and gradually decommissioning your on-prem applications and will move them to cloud. But you can't turn off the switch on one day. So the period of time when you are running both the services in parallel, that is where your cost will move up. So it will reach a peak and then it will come down. So like any other business, initially you have to invest in the business and then it will reach a break-even point to give you return. So that's the same way with cloud. Initially the cost will go up, then it will start coming down and it will reach a break-even point, and then in a couple of years, depending on the size of your organization, your agility, etc., you would be actually able to see the return on investment. And that's how you should also like convince your executives that it is cloud is giving you modern capabilities, but at the beginning there would be a little bit of more cost that they would have to incur and have that investment. It's almost an investment. Okay, so I guess that is it from the question stance. Is there anything else? Okay, another question. Any cost saving techniques in cloud for smaller or medium sized groups? Yes, of course. I think the cost saving techniques in cloud for smaller or medium sized groups is go take an approach of pay as you go and get really, really good at pay as you go, like infrastructure as a service, infrastructure as a code. Like get yourself like essentially, you if you are like, I have experienced it myself in my, like I do a lot of experimentations on the side just for playing and having fun. I mean, for 1 year I configured like a very heavy a machine and on the cloud with 128 gigs of memory and a few cores of processor, and I only turn it off when I need it and then turn it off when I don't. And I was able to use a machine with that kind of capacity for about last year. I paid about $400-ish for my entire usage for last year. And if I buy a similar like machine, like let's say a MacBook, no, not MacBook, essentially a Mac Pro, it will cost me 4 or 5 grand at least to start with, and then it will have a life cycle of about like 3 to 4 years. So because using that pay as you go, and I essentially, the better you get at pay as you go, you will find, particularly for smaller organizations where you do not have that legacy enterprise problem to kind of move massive workloads to cloud. If you harness that pay as you go skill very well, you would be able to get quite a bit of advantage. Okay, which cloud solution will I suggest? No, I will not suggest any cloud solutions. They are give or take the same. So because it's like almost answering like whether I would like give or take whether I use like essentially GCP, Azure, and AWS. They have like their own advantages and disadvantages. AWS is more IT centric. Azure is also more IT centric. GCP's value proposition is more on the AI ML space, but they can also be infrastructure centric and IT centric. So they are give or take the same. It really depends like what type of organization you are and what type of use cases you are trying to solve. So they are largely the same type. They provide the same type of services, and without knowing your organizational goals, without understanding your like type of workloads you want to run, without understanding what type of your data residency requirements, etc., it's very hard to say that okay, this cloud is better than others, because at the end of the day, those would be your decision making point, right? Data residency, workloads, agility, cost, and your overall nature of your organization, what type of DNA your organization has. Yeah, absolutely. I can share my contact. Like I'm typing my email here. That's my personal email. So you can always reach out to me in my personal email and search my name on LinkedIn. I'm sometimes slower on the email, but I try to be rapid. I check my LinkedIn regularly. So LinkedIn is the best way to contact me. So you can search my name on LinkedIn and on Twitter. And that's how I can also be connected, but more than happy to answer your questions or any further conversations that you may want to have on my email as well. I can't, Rilov, I can't recommend a particular technology framework like Kubeflow or hybrid computing model yet. There are many of them are available. Like as I said, they are give or take the same. Without doing a thorough assessment of the use case, it's hard to say this versus that. But I know that Kubeflow in the past, my engineering team has used Kubeflow, and we have been quite successful in utilization of the of that service. Okay, thank you, everyone. This is fantastic. I was able to share my 2 cents here. Hopefully, it was helpful, and I am really optimistic to see you again next year, and in person possibly. Okay, I'll then drop.